So once again, I welcome you all to our virtual webinar on AI in action. Let's embark on this enlightening journey together. So it's with a great anticipation and enthusiasm that we extend a heartfelt welcome to our today's special guest speaker, focusing on AI in action. As we gather in this virtual realm, we are honored to be joined by Mr. Malinda Alahakon, an experienced lecturer and dedicated science communicator with over a decade of experience in academia. He has also expanded his platform into digital sphere as a science communicator. He has created insightful educational videos that make complex scientific concepts accessible and captivating to a broader audience. So without further ado, let's extend a warm virtual welcome to Mr. Malinda Alahakon and prepare to embark on an engaging journey into the realm of AI in action. We are delighted to have you here with us, and we are eagerly anticipate to insights that you will share. Over to you.
Hello, guys. If you already have the slides that I sent you, would be nice if you share that so that. And everyone, thanks for inviting me. And if it's a little too noisy, apologies, because I'm not at my office. So usually, yeah, I pay so much attention to audio and the video quality, but not today, guys. I'm sorry. Maybe another day with better production quality. And can I get the slide shared, please? And
yes,
in the meantime,
sure,
guys, yes. And in the meantime, I'll explain you the primary objective of this session. So I know many of you are astronomy and space exploration enthusiasts. So AI is developing, and I'm pretty sure that all of you guys are like really concerned, or not concerned. You guys are like energetic, motivated about how AI is going to inspire or change the space industry and the space exploration in the next few decades. And that's the main idea. But before we get to that point, we have to pay a little attention, and we have to understand what does it mean by AI, why AI became a huge deal in the last few years, what exactly happened there. And yes, that's the slide I was looking for. So for that, we have to understand what kind of areas in this whole AI thing. In this AI, we have machine learning. That's one section. In machine learning, we have three different branches. That's supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is something like parents teaching kids. Like, let's say I have a kid. I'm telling my son that, hey, son, this is a dog. Then I'm showing him a Sri Lankan dog. Then my son come across with, like, let's say, what? A golden retriever, right? Then my son might ask again, like, hey, dad, who's this one? I'm going to tell my son that, okay, this is also a dog, but a different breed, but still a dog in the same category. Then after a little bit of training, my son can understand, okay, these are dogs. But one day, my son is going to come across with a cat. And based on the previous data, he might say that, hey, dad, look, a dog. Because 4 legs, tail, and fur, and everything. But then I'm going to tell my son that, hey, son, that's not a dog. It's a cat. Cat has fur. Whiskers, not fur, whiskers. And dog is saying woof. The cat is saying meow. Like that, I'm creating a new category. So this is basically supervised learning with label data. We are telling the neural network in our head that these are dogs, these are cats. If you want to try this thing out, I strongly recommend you to go to this tool called Teachable Machine. It's by Google. Go to Teachable Machine and you can see this yourself. And the primary objective here is we don't really have to code everything. we can actually train the machine like the way we training another human being. So that's supervised learning. Unsupervised learning would be something like I'm going to give a bunch of coins to my son, and I'm asking my son to categorize them. So then he'll probably figure out all the 50 cents. Oh, we don't have 50 cents anymore. We don't have 50 cents anymore, right? Sorry, guys, no 50 cents anymore. We have a rupee, 2, 5, 10, like that. He's going to categorize, right? So after categorizing them, I can tell my son that, hey, son, these are 1 rupees, these are 2 rupees, these are 5. So we do the categorization first and then we label them. That's unsupervised learning. And I'm pretty sure that all of you guys have pretty good idea about this stuff, because I got a little question prior to this session from you guys asking, some specific technique that we are using in unsupervised learning. I don't really remember the word. Anyways, we'll get to that later. Then we have this thing called reinforcement learning. Reinforcement learning is something like, let's say you want to learn how to play chess or carom, okay? But you don't really have anyone to play with. So what we usually do is we play with ourselves. Like, I'm pretty sure that many of you guys have done it. Like, let's say I make the move for myself and I imagine that in the other side I have my brother. This is me, this is my brother, this is me, this is my brother. If you are doing this thing 100% with 100% honesty, then with any opponent you can learn chess, right? That's reinforcement learning, one of the magical thing in artificial intelligence. We are doing all of those things on top of neural networks, and we have multiple layers of neural networks, actually multiple layers of neurons. That's what we call the deep learning. This is a like very high level summary, guys, but you need this thing to understand what I'm going to talk about like after this point. And can I have the next slide, please? And in the meantime, if you guys have any questions, please drop them in the chat so that I can see it. And the next thing is, guys, transformers. Now, the transformers that you're seeing in electricity grids, these are different transformers. The original research paper was published by some Google engineer, as I remember, back in 2017. One of the biggest problem when we are dealing with language is, like, look at me now, like I'm giving you a series of words, right? So then you decode the series of words and then you understand what I'm saying. So it's a pretty sequential process. So when you're handling sequential processes with computers, we can use only one CPU core, if you know what I mean, right? So we have a string of text and we had to get the first letter, second letter, third letter, and we had to do it strictly sequentially. If not, everything is going to be messed up. So that was one of the biggest problem that we were facing when we are dealing with language in our artificial intelligence. Everything strictly sequentially. So it's going to take ages to process huge amount of text and language. But in 2017, one Google engineer came up with this transformative idea called transformers. So he figured out a way to feed a language simultaneously to a learning machine. So they are using positional available to humanity to process language. So I'm pretty sure that all of you guys are doing, you are gaming. You are gaming. So when you are gaming, you are using GPUs. In GPUs, we have thousands, 2,000, 4,000 CUDA cores in NVIDIA GPUs. So now that we can use like thousands of parallel processors to handle language, hence we have this thing, the large language models. Now that we can scale language model to like millions, billions, or trillions of parameters. Can I get the next slide? Right, so that's parameters and compute. So when we increase the number of parameters, when we increase the amount of compute, then those language models are getting pretty close to human. human capacity. So that's what we are experiencing today. But we have a little problem here. So we are increasing the parameters on the compute. Nothing happens. We double it. Nothing happens. Can I get the next slide too? Oh, right. That's exactly what I was looking for. You get nothing. You triple it, you get nothing. You quadruple it, you get nothing. But at a certain point, some ability in this neural network emerge. Like we honestly, not just me, like nobody knows how it's happening. We have some theories, but it's emerging, right? So then we use it. DALI, ChatGPT, Claude, and all of those or Perplexity or anything, Google Gemini, anything we are using is some sort of emergent behavior of this neural network. We scale it and then we scale it, nothing happens because the output we are getting is not proportionate to the compute. Not proportionate. Sometimes the features emerging. So that's what we call the emergent behavior. Personally, guys, I think that's dangerous because we are dealing with something that we don't know, right? But I still think it's useful. So that's why we have really good large language models and the image generators and even the video generators. But we have to solve this problem if you are going to proceed any further. So that's why we have the next idea called the explainable AI or the XAI. So in this session, I'm not actually planning to dig deep into explainable AI techniques and stuff, but I'll give you some searching points. So local, interpretable, model agnostic explanations, it's mouthful, guys. We call it LIME. So give it a little try. I strongly recommend you to go to Google Gemini, the free version, and ask what the hell is this thing is. Local, interpretable, model agnostic explanations, or LIME. Believe me, guys, Google Gemini will give you a very comprehensive, really good explanation about this thing. Then we have this thing called SHAP. Through all of those concepts, we are actually trying to understand how deep neural networks are working in its deeper core level. But we still don't have a solid solution yet. Usually, any kind of artificial intelligent machine is a black box. We can ask something, it's going to give us some output, but we totally don't understand what's going on in there. We have some idea, but that picture is not 100%. So that's why we are looking for XAI or the explainable AI. That's going to be a huge problem that we have to solve in this decade if we are going to move forward with artificial intelligence in the coming few decades. So we have to sort this out. Otherwise, like we are dealing with something we don't understand and we'll get lots of unexpected results like hallucinations and incorrect results and that kind of stuff. And the next thing is, and can I get the next slide? Yes, the quantum AI. You know, the quantum computing is there. The quantum computing is there for very specific tasks. Those specific tasks are usually simulations or tree search. When we are traversing through a tree, a probability tree, we go through one branch. If we get the result that we are looking for, yes, we are happy. Or we have to come back and go through a different branch. So we have to do all of those stuff again sequentially. But I'm pretty sure that all of you guys know about the quantum behavior. The quantum particles can be like, let's say, spin of an electron can be up, down, and any combination of up and down. And when you're not looking at it, it's in superposition. So it's not up, not down. It's not a combination of up and down too. Yeah, it's in both up and down at the same time. So these quantum computers can go through probability trees simultaneously. It's a weird idea, guys, but that's exactly happening there. So we figured out how to use these things. And when we are using artificial intelligence with quantum algorithms, finally, eventually, we might get some use cases. One of the biggest problems with quantum computing is we don't really have proper use cases for quantum computers. So most of the stuff that quantum computers are doing, the classical computers also can do, maybe in a much better way, in a much cheaper way. So with artificial intelligence, maybe we might be able to do proper simulations for proper future projections maybe future stock market projection and that kind of crazy stuff with quantum computing plus artificial intelligence, maybe one day. Lots of concepts are there, but we don't really have any proper use cases, but I'm expecting something in this decade and the next one. Then people, this is the holy grail of artificial intelligence. One day, we will be able to build a machine that can mimic all the capacity, all the features of human brain. We call that the artificial general intelligence. I'm pretty sure that we are very close to AGI already. That's going to be the holy grail, guys. So at a certain point, we have an intelligent machine that can do everything we can do, and we have advanced robotics. They can do everything we do. Then what are we supposed to do? So that's a really good question. It's a really good philosophical question. We still don't have answers for it. So now that we are living in a capitalist world, so I understand your requirement and I offer it. You pay me money. Then I spend that money to fulfill my requirements. So that's how these markets are working. But at a certain point, this idea of money might become irrelevant because of AGI, because everything we need to consume is already produced by intelligent machines and robotics. Then what are we supposed to do then in that kind of world, that kind of utopian world? We can actually focus on the creativity and higher beings and that kind of stuff. Maybe, I don't know, guys. So probably with AGI, we can actually go to a communist world. So everything we produce is shared. So we don't really have to exchange money or struggle for resources and that kind of stuff. Guys, I don't know whether this is going to happen or not, but it's just a crazy idea. AGI might enable it, a communist world. Then, I know that you guys are like really motivated to know how the artificial intelligence is going to affect space exploration. That's in the next slide. There you go. So we are already using artificial intelligence to most of those stuff, guys. Like, you'll be surprised. So satellite data processing, we are already using artificial intelligence. Then the space debris tracking and avoidance, we don't use artificial intelligence fully, but we are using computer algorithms. Of course, you might have seen it. Like, we avoid lots of collisions within this year, right? You probably have records of it. But yes, we can use artificial intelligence. But one of the biggest problem here is when we are using artificial intelligence, the output is not 100%. When we use a computer algorithm, and if you develop that computer algorithm in a clean room environment, the output is 100%, guys. Like, we know exactly how it's going to happen. So, but when you're using artificial intelligence, it's good enough, but never 100%. That's why we can never use artificial intelligence to operate something like traffic lights. But we can do something useful there. Then the autonomous navigation, it's already happening. We have rovers and lots of other things in space beyond Earth. Those things are using artificial intelligence, the robotics rovers, and the automated scientific experiment, guys. This is a really interesting idea, the thing that we can do with artificial intelligence. So usually we design the experiment, we conduct the experiment, we collect the data, and then we interpret the data. But sometimes, like, let's say you have a research lab in Mars. How are you going to do all of those stuff? So, like, let's say we have thousands of different research designs, and we have to conduct all of those things. We can use artificial intelligence to generate all of those test cases and implement them using robotics and collect the data and send the data back to the Earth with this kind of artificial intelligence and advanced robotics. It's going to be pretty exciting, and I'm pretty sure that all of you guys watched the Starships Integrated Flight Test 3. That was pretty freaking amazing. So we are getting closer to Mars inch by inch. So one day, maybe within the next few decades, we'll be able to go to Mars and set up a lab there. So then this kind of tool is going to be super handy. Then exoplanet discovery. You know that when we are using radial velocity method or the transit photometry to identify exoplanets, so of course we can use image recognition to do that kind of stuff. Like, I'm pretty sure that many of you guys are doing those asteroid hunting camps. Do you? Like, if so, please drop a message in the chat. you go to you get a huge number of images from some observatory, then you are comparing image one by one, and then when you spot something moving through the stars, and that's probably be an asteroid. I'm pretty sure that you guys have done that kind of stuff. So AI can do that kind of stuff easily. But still, when we are dealing with very noisy images, humans are still better, but AI is getting better. We can train AI to identify exoplanets and asteroids and that kind of stuff. And when we are detecting a planet using transit photometry, then the planet is going in front of the mother star or the host star. Its brightness is going to get a little dip. So we can't look at all the stars at the same time. So we can ask the AI to deploy AI agents to look at all the stars at the same time. Then we can detect more exoplanets. We are already doing this, by the way. Then the habitat and life support optimization is also an important thing, because when we go to space, when we go to Mars, we have habitats and we need life support systems, and we have resources, and we have to utilize those resources. I'm sorry. We have to utilize those resources to solve our problem. So for that, guys, we can use deep learning and reinforcement learning. Can I get a tissue? A second, please. Okay, so let's say on Mars, we have some resources. On Moon, we have some other resources. We can give some kind of artificial intelligence those input resources. Then it can look at all the possible combination and figure out a way to build houses on Mars, build houses on Moon, and that kind of stuff. So that's one possible. That's one possible application of AI in space, guys. Then this thing is again already happening. Spacecraft design and manufacturing. Design, we are using AI. Already we are using AI. And of course, there has to be a human expert to assess those output and optimize those output. And the manufacturing, we are already using 3D printing and robotic and that kind of stuff. And this thing, the predictive maintenance, I'm not really sure whether we are already using this thing, but we are using this thing in civil engineering already. Like, let's say there's a huge bridge. We have lots of cameras around it. The AI is using the camera feed to notify maintenance engineers, okay, you have to pay attention to this part. It's not broken yet, but we know it's going to be like something's going to happen in that area. We call that the predictive maintenance. For that, we can, of course, use AI. And my favorite part is mission planning and simulation. When we were planning the Voyager, none of you guys were born back in the days, neither do I. So when we were planning Voyager 1 and 2, it has to be like planning such a way to use all of those external forces in a perfect synchrony. Otherwise, it won't go to the place that we want it to go. So we can do all of those stuff in simulation. And just think, guys, if we have perfect simulations, do we have to do integrated flight test of Starship? I guess not. Like, we can do all of those stuff in a simulation, but we don't have perfect simulations. So maybe with quantum computing and artificial intelligence, maybe down the time, we'll be able to simulate the environment in a perfect way. Actually, scientists are trying to do it. So we call that the general world model. Simulate everything on this planet or maybe in the universe. Then Elon Musk don't have to send the ship to space and collect data. We can run a simulation and collect data. So those are going to be trends with quantum AI. I didn't talk about AGI here because we don't have it yet, but we can use all of this stuff here. And yes, guys, I think I gave you an eye-opening, and I'm pretty sure that you guys already have a long list of questions. I got the list of questions, There you go. I got the list of questions, and I think this would be the time to ask. And Nimna, would you like to shoot the questions this way?
Yes, so participants, you all can send us your questions for the chat, so then I can read it out. So I'll go ahead with my first question. So that is, will software engineering jobs disappear due to AI?
The short answer is yes, they'll be disappeared. But we have to understand that the software engineer is the lowest position in a huge hierarchy. So we have the associate software engineer, then we have the software engineer, then we have the senior software engineer, then we have the tech lead, project manager, software architect, and there's a huge hierarchy. So because of the advancement of AI, the software engineer is going to need less number of associate software engineers, right? I am a writer. I have assistant writers. So now that I have AI, so I don't really need lots of assistant writers. I need a few assistant writers. So some of them going to lose their jobs, so they have to upskill and come up to the next level. So yes, all the repetitive jobs, all the lower level jobs is going to be replaced, and that's going to slowly climb up. So at this point, if you're actually trying to write a code and you're spending time to write a code, it's becoming useless. So you can simply use any kind of a large language model to generate the code you want. But generating a code is small part in software development, software engineering, or software architecture. You have to pay attention to the hardware architecture, software architecture, how everything is going to connect with each other. So yes, these associate software engineers, basically the coders, you guys are in danger. You have to upskill. You have to understand the software architecture, the hardware architecture, how to solve problem, how to be creative, and that kind of stuff. If you only know how to write code, you're screwed.
Oh, thank you for that. And since you mentioned that we need to upskill, can I know like how to become an AI engineer after having a software engineering degree?
Yes, I'll try to be more generic than that. So back in the days, like we used to say that like if you can get the job done, the theoretical knowledge doesn't matter much. We used to say that, right? That thing is actually changing. So now that you have to have a good theoretical understanding, if you don't have good theoretical understanding, you can't explain the task to a large language model, right? So I'm a writer. So when I write stuff, sometimes I'm asking ChatGPT or Claude to write this thing in a inverted pyramid style. So I can ask that because I know inverted pyramid, right? So sometimes I'm asking ChatGPT to do a disk analysis. That's because I know about disk analysis, right? So if you are a software engineer and you know how to copy paste some code from somewhere, Stack Overflow or somewhere, some other places, and compile it and get the thing running, and guys, you are in trouble. Because in the future, in the next few years, you should be able to explain a large language model what exactly you need. Then large language model will generate the code for you. But to explain that thing, you should have a solid theoretical background. So in any field, if you are working in any field, get a good theoretical background. Then you can actually work with large language models. Your job will never be replaced by an AI, but your job will definitely be replaced by a person who's using AI. So be prepared for that. Be that person.
Thank you. So we have a lot of questions coming in, and we have some long question from Situm in the chat. So I'll read it out. He's saying, I'm currently working on Singular AI Assistant. The biggest problem I have is the low accuracy of Google Translation API. I'm trying Singular, but it's not also supporting English to Singular conversation properly. What are the alternatives I have? Is it true big companies like Bhasha Helakuru is working on Singular LLM?
Right. That's actually an interesting question. If you want to build a large language model optimized for Sinhala, bro, Situm, bro, that's going to be a one hell of a nightmare. Because first you have to get all the training data. We have some training data, yes, but Sinhalese is a pretty complicated language. And then all of those things gonna cost so much money to train that kind of large language model. I'm not really sure whether big companies are doing this kind of stuff. So remember the first version of ChatGPT, their training cost was like more than $100 million. So it's going to be a huge task. So my recommendation is, Situm, like if you're going to do this kind of stuff, you should have a solid business model. So if you do this, how are you going to monetize it? How are you going to fund it? And that you have to find answers to that kind of question. If you can, then you should probably go ahead and do it. But this is a humongous task. So it's gonna use, you're gonna need so much money, so much processing power, huge amount of text data. I don't really think, I'm not really sure. These are only a guess. Even like no Sri Lankan companies trying to do this scale of stuff using Sinhala. Only a guess, by the way. Maybe they are already, I don't know. But it's a huge task. And I'm still thinking about the utility of it. Like who's going to use it?
Nice. So we have another question from Tharusha. He's asking, how does NASA use AI in astronomy?
Right. Tharusha, I gave you a couple of examples in the slides. Could you please go to the previous slide? Yeah. Oh, there you go. So, guys, NASA is doing most of the stuff already. Satellite data processing, space debris tracking, and the robotics rovers, like all the Mars rovers, they don't have like very advanced AI, because when you increase the complexity of AI, the unpredictability also goes up. So they are using some kind of AI to do that kind of stuff. Should probably have heard of the Mars re-entry. It's fully automated, but again, not really AI. It's a very discovery, because I remember once Google and NASA had a collaboration to do that kind of stuff.
We have a question from Shrikant. He's asking, can the combination of physics and computer science make a huge impact in future?
Yes, the combination of physics and computer science can make a huge impact in future. The combination of physics and computer science. Yes, because a combination of STEM subjects is going to make a huge impact on humanity anyways, guys. Because look at us now, like we are doing all of those stuff. I'm in a restaurant and we have Wi-Fi, and we are doing all of those stuff because of different combination of different STEM subjects. So the answer is an easy yes.
All right. So Dinindu is asking, if we want to learn AI further, what are the free resources that we can access to?
Right. Dinindu, most of the free resources are on YouTube. And some of the big universities are releasing their courses on YouTube. You might have seen like big universities like Harvard, Stanford, they're releasing some of their lectures to YouTube too. And we have Coursera. Coursera has some good free courses offered by big universities again. So if you have that level of discipline, that would be the best path to walk down if you want to learn AI.
Next question is from Arosha, which is, what will happen to the language that we use daily with the development of AI? Will the whole world use only language like computing?
Right. Arosha, you're actually asking a philosophical question, because language is one of the biggest limiting factor in human brain. Just think, Just imagine, guys, like if I can copy paste all of these thoughts to your brain in a matter of milliseconds, we don't really have to do this thing, right, Nimna? We don't really have to do this thing using the language. If I can simply copy paste these ideas to your brain, for some reason we can't do that yet. So that's why we are spending like nearly 1 hour doing this thing, like using language. Artificial language is a critical limiting factor in human brain. Maybe through computers we'll be able to solve this thing, but I'm not really sure. And all of you guys use a unified language. I don't really think that will happen in the near future. Arosha, humans as a herd, as a species, we have this tribal mentality anyways. We like to be separated. So I don't really think that will happen in the near future. But the large language models will do something else. At a certain point, maybe by the next year, when I'm sending an email, that email is written by a large language model. And you get the email and you write the reply with a large language model. At a certain point, this human to human communication will break down. So we will have lots of large language models talking to each other at our will. That thing will happen for sure.
Next, we have a question from Gimhani asking what kind of change happens to you IUX field because of AI?
Right. So even yesterday, I had a little chat with my friend who is a software engineer and a startup owner. AI is pretty bad with UI and UX even to date. So if you are an AI engineer, UI UX engineer, AI is far behind yet. So again, like when it comes to video editing, AI is far behind. But at a certain point, AI will get to you. So what you should do is you should upskill yourself. So that's a common pattern anyways. So at this point, like if you want to write a piece of code, you can simply ask a large language model to write this code for me, easy peasy. But if you want to get a UI or UX design by an AI, you can simply ask the AI, hey, can you give me this kind of UI UX? The results are still subpar as far as I have seen. So yes, but eventually AI will get you. So be prepared, upskill yourself.
We have another question from Akash asking what are the possibilities of AI models going to develop their own AI models in future? If that happens, how can we still be sure that we are in control?
We don't really have an answer for that question yet, but AI model can most certainly develop another AI model. Yes, they can do it. I'm pretty sure that there are some experiments. We already did it, and we are still actually discussing about those things, and that's why most of the AI experts across the planet thinking that we should slow this thing down a bit, and we have to figure out all the rules and how we're going to respond to all of those things. And when we have answer to all of those questions, then we should progress with AI. We don't really have answer to these questions yet, and we should pretty soon.
All right. So next is Minur's question on he's saying some experts even say that AI development should be stopped. Is it true?
Yes, sir. Some experts are saying that they don't really say that we should stop it, but they are saying that we should slow it down. We have to figure out how this AI is working, and we have to understand why the emergent behaviors are there. And we have to figure out some ground rules, and we need some controlling mechanisms. Once we figure out all of those things, then we can proceed really fast, yes. But now that we are proceeding really fast and releasing lots of AI tools to the public without having answers to all of those questions, and I think that's a little dangerous. Yes.
Moving to the next question from Tehan. So he's asking how to use AI for businesses.
Sorry, I didn't catch that question.
How to use AI for businesses.
Okay, so if you are doing not just business, anything, The first step would be like you should write down all the steps that you are following to complete something. We call that the workflow diagram. Once you have a workflow diagram, you have something, you have some stuff that only a human can do, not just a human expert can do. So when I'm producing videos, sometimes like I have a workflow for video production, there are some steps that must be done by me. Like no one else can do it. But there are some steps someone else can do it. There are some steps that an AI can do it. So when you have a workflow diagram, you can easily figure out that where you can implement AI. This is not only for business, for anything. First thing, draw a workflow diagram. Then you will see steps that AI can do.
Thank you for addressing all these questions from the audience, Mr. Malinda. But we have so many questions coming in. So let's move to the next one. It's saying, what's your idea about job market for a prompt engineer in the near future?
The simple answer is zero. Yes, lots of companies were looking for prompt engineers, but I don't really think that we're going to need a prompt engineer to talk to large language models, because large language models will be so much better that it can understand anything that we are saying. Like, if I can explain something to you and you can understand it, and the large language model also can understand it, and the prompt engineering will easily become obsolete and irrelevant. So don't pay too much attention to prompt engineering. Instead, pay attention to your subject and its theoretical background. Then you can explain something really better. Like, let's say I'm in front of a high-rising building, and when you are building this kind of stuff, then you have terminology, right? Like you have to explain this thing to the construction workers, engineers. So if you know those words, if you know those terminology, if you know the theoretical background behind this whole thing, then you can explain it to someone else. Get that skill. Don't pay too much attention to prompt engineering, because large language models are so good. If you can explain something clearly, then you are already a prompt engineer.
Thank you. So the next question is, how can some software identify AI generated content?
What they're basically doing is they have labeled data. These documents are written by humans. These documents are written by AI. Then they are using again machine learning to identify all of those things. And they are using mainly they are using two different things, which is perplexity and burstiness. Just go to Google and search for those things. There are like equations for those stuff. When humans are writing, perplexity and burstiness is high. But largely, most of the AI content detectors are using label data. These texts are generated by AI. These texts are generated by humans. Then after a certain point, they can figure out.
All right. Next question from Vidas is that, can AI act as a scientist?
Scientists are actually creating new knowledge out of nothing. I'm not really sure. Whether they can be a scientist, but one day, for sure, AI will get that capacity. One day, but not today.
Sure. So next is, do we have any ethical standards for AI? How we know those AI inventions are under control?
We don't know, and we don't have like solid legal framework or solid ethical framework. And that's exactly why most of the AI experts are saying that we should slow this thing down and figure out all of those things, and then we should move on.
Sure. So we have so many questions coming in. So let's move to two more questions. So next is, what is your idea about selling AI generated designs or artworks in relevant markets, just giving the prompt, generating, then selling? Yeah.
Right, you know what? So, like, let's say I am creating something in, let's say, Midjourney. then I have a prompt, and I give you the same prompt, and you use the same mid journey, you probably get a different result. Not the exact same result, but a different result. So I don't really think that there is such a thing called AI generated art. I don't really think there's such a thing called AI generated text. There are human generated art, human generated text using advanced tools. So I don't really like to categorize it that way.
All right. So we are going to give the chance for one more question out of so many questions that we are getting in. So let's move to the question that how AI were created.
How AI were created? You know what? Like that's going to be a really long answer, Nimna. So I'm gonna need like another 1 hour to explain that.
Okay. So then let me pick the last question. Okay, I'm sure this is going to be the last question. Yes. So they're saying in future, as for the development of models like AGI, which can adapt and learn, what can happen if can be controlled if such a model adapt destructive behavior?
Again, Ranuki is asking this question. Ranuki, we don't know. And that's why most of the scientists, engineers are thinking that we should slow this thing down a bit and figure out answers to all of those questions, then we should proceed. And you know what? This could easily happen because we are trying to build a machine like human brain. Humans are violent, right? So we are not violent because we have a solid legal framework. If not, we are violent creatures. So if we are trying to build a tool which is mimicking the behavior of human brain, there's a significant probability for that to be violent. So yes, but we don't really have answers to those questions yet. We have to figure those things out and then we should proceed. That's why we have this, in AI world, we have the slow team and the fast team. I'm also kind of in the slow team.
Thank you, Mr. Malinda, for all those insights and for answering so many questions from our participants. So, distinguished guests, esteemed speaker, Mr. Malinda, and our valued participants, as we draw the curtains on this captivating journey through the realm of AI in action, it is with immense gratitude and heartfelt appreciation that we extend our sincerest thanks to each and every one of you who contributed to the success of this virtual webinar. First and foremost, we express our deepest gratitude to our esteemed speaker, Mr. Malinda Alahakon. Your expertise, insights, and passion have illuminated our understanding of AI's transformative power, leaving us inspired and enriched. Your willingness to share your knowledge and experiences have been invaluable, and we are truly honored to have you here today and be learning from you. Also, we extend our gratitude to all our participants. Your active engagement, thoughtful questions, and enthusiastic participation created a vibrant atmosphere of learning and exchange. Your presence has been the driving force behind the success of this webinar, and we are immensely grateful for your contributions. We would also like to extend our appreciation to the organizing team whose dedication, hard work, and planning made this event possible. Your commitment to excellence and attention ensured the seamless and enriching experience for all involved. Once again, thank you to everyone who contributed in making this virtual webinar on AI in action a memorable and enriching experience. We look forward to future opportunities to learn, grow, and innovate together. Thank you.